Today, we'll walk you through the construction of a subway station, highlighting key stages and safety procedures, using Fuzor Event Trigger System. Here is a dialog box created from the Event Trigger System. By clicking the designated button, users can review different parts of the construction sequence that they are mostly interested in. Here, let me show you how it works. Let's have a look at the location of the subway station and what are the road closure needed for construction. Click on the button over here and Fuzor will take you to construction details. First, we identify the location of the subway station. The construction location took place in between Kings Road West and Kings Road East. We will first assess the location and plan the necessary road closures to ensure safety and minimize disruptions. See how Fuzor shows you the construction stage in different camera angle. Now let's proceed to the preparation of the construction site. The site is prepared by clearing the area, setting up barriers, and ensuring the ground is stable for heavy machinery. Next up, let's move on to the road demolition. But wait, safety is our #1 priority. Let's check out the safety procedures to ensure the worker's safety. Throughout the construction process, safety is our top priority. Workers follow strict safety procedures to ensure a secure working environment. One of the ways to ensure safety on site is by placing engineering controls such as barriers, fences, and safeguards. These will help isolate workers and other personnel from hazardous areas. Workplace safety signs should be highly visible on the construction site to ensure your workplace occupational health and safety requirements. They are used to addressing any hazard, danger, or other information workers and people entering the workplace need to be aware of. Now we begin the construction with road demolition. Next, the existing road is demolished to make way for the construction of the station. Construction vehicles and machinery such as excavator, demolition robots and demolition hammer are widely used for the road demolishment and evacuation. The demolition waste from destruction of road and sidewalk will then be excavated, gathered and transported to a designated facility for disposal or recycling. For road demolition, construction vehicles are used for breaking the existing asphalt into small pieces and removing them. Repeat the process until the road section is fully demolished, ready for the next construction stage. Once the road and sidewalk is demolished, a diaphragm wall method is performed. Using the diaphragm wall method, we create a watertight barrier to support the excavation of the station box. First, a trench is to be excavated. Repeat the process until the trench excavation is finished for the panel excavation later on. By utilizing the crawler crane, grab the steel and insert them into the trench for the guide wall. Then install guide wall at working platform level. Typically 2 parallel concrete beams to control panel alignment. Excavate rectangular panels with diaphragm hydraulic grab. Meanwhile, bentonite is being bumped to support trench excavation, enabling excavation below groundwater table in all ground conditions. Now the panel is excavated, we are ready for the next step. A reinforcement cage is used constructively in the panel for support and ensures the transfer of forces from the structure to the bearing ground or base. Place the panel reinforcement cages and tremie the concrete. A tremie is used to pour concrete underwater in a way that avoids washout of cement from the mix due to turbulent water contact with the concrete while it is flowing. Repeat the process until all support walls for the station box are completed. Now, let's find out more about the cut and cover method. The cut and cover method involves excavating a trench, constructing the station structure, and then covering it back to restore the surface. In the cut and cover approach, construction begins by excavating a large open trench at ground level. Once the trench is dug, a support structure is built to protect the sides and prevent collapse. The construction then proceeds downward in layers. The top-down method allows excavators and workers to perform excavation underground. As the excavation deepens, the tunnel structure is built incrementally. A bracing system is added to improve the cover slab's ability to withstand forces and minimize damage to the structure and its occupants. Vertical braced frames are installed at regular intervals, and then the deformation of the walls is prevented by placing a horizontal braced frames between these vertical braced frames. Let's check out how the road being restored and reopened to traffic. The surface is gradually restored as construction proceeds deeper into the ground. Once the major structural work is complete, the road is restored and reopened to minimize disruption to traffic. Now, let's check out the step-by-step process of the station construction. Inside the station, we proceed with the construction sequence, installing tracks, platforms, and necessary systems. The top-down construction method allows the temporary support of excavation walls are used as the permanent structural walls. The structural slabs will act as internal bracing for the support of excavation, thus reducing the amount of tie-backs required. It may result in lower cost for the tunnel and also a shorter construction duration by overlapping construction activities. The tunnel boring machine, also known as TBM, uses the huge cutting head to break soil and rock. The TBM then places curved pieces of concrete to make the newly dug tunnel watertight. Conveyor belts and pipes inside the TBM take the rock and soil to the end of the machine and then to the surface. Once the overall structure of the platform is completed, electrical and mechanical equipment and systems were to be installed. With the station completed, we see the benefits of efficient planning and execution. Thank you for watching our interactive demonstration using Fuzor's event trigger system.